All right, so we've looked at a polynomial to see what that is. Now let's do something with a radical in it. We're going to let f of x equal the square root of 2, and then plus 1 is outside of that radical. And we want to find the equation of a tangent line, dun, 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 derivative, when a is equal to 2. So in this problem, I'm only given that a value, which we know is the x value, that input value. So when we go to find the point and the slope, right, the slope is my derivative. The point here, if I do f of 2, that's going to be 2 times 2 plus 1. So f of 2 here is going to be 3. So this is my point. You see that? 2, 3 is the point, f of 2, because you got the square root of 4, which is 2 plus 1 gives me 3. Okay. So now I have a point. We have to figure out the slope, and that's where we get to do the derivative. All right. So f prime of x is equal to f of x plus h minus f of x all over h. Until you, whoa. Are you yelling at me? You should be. What did I forget? Limit, yo. That's a big deal. The limit as h approaches 0 of all of this stuff, of the difference quotient. Good. Well, I hope you were yelling at me. I'm so proud of you. Okay, let's do this. Finding the generic derivative. I haven't taken my limit yet, so we just got to keep writing it. This is the square root of 2 times x plus h plus 1 minus the square root of 2x plus 1. Make sure you put those parentheses around there so you can distribute all over h, right? Distribute this negative sign. And what do you see happens right off the bat? Yeah, plus 1 minus 1 cancels out. That's nice, right? Okay, so let's rewrite this here. And I'm left with f prime of x equals the limit as h approaches 0 of the square root of 2x plus 2h minus the square root of 2x all over h. Now, this is not something that I can just algebra down in terms of combining like terms like we did with the polynomial. What do you think we need to do here? Yes, the conjugate, just like we did in the last chapter. Well, look how that came in handy. Surprisingly not. Right? So conjugate. 2x plus 2h plus 2x over, remember, whatever you do to the top, you have to do to the bottom. 2x. Okay. Then, this is the difference of squares. Square the first term minus square the second term, right? That's that same pattern that keeps showing up when you do a conjugate. That's the whole point of the conjugate. So I have the limit as h approaches 0 here of 2x plus 2h minus 2x because you're squaring, oops, meant to do this. You're squaring a square root, so the square of the square root cancels. Okay, all over h times the square root of 2x plus 2h plus the square root of 2x. Ooh, check out what's happening here. Plus 2x minus 2x. Now, I'm going to shortcut this up a little bit. You see 2x is the only thing we have left. Or pardon me, 2h is the only thing we have left on top. So I'm going to go ahead and cancel those h's. And this derivative will be the limit as h approaches 0 of 2 over the square root of 2x plus 2h plus the square root of 2x. Do you see that? It's okay that there is an h in the denominator here because it's not multiplied. That's the key. Remember that? So as long as it's added or subtracted, that's legit. I just can't have it multiplied. So now I have 2 over the square root of 2x plus the square root of 2x. So 2 over 2 square roots of 2x. Do you see what's happening here? The 2's cancel. And I'm left with 1 over the square root of 2x as my derivative. Nice, right? Okay, so if this is my derivative, what's another word for derivative? The slope of the tangent line. Good. So I know that this is now my generic slope formula. So I'm squeeze it down so I can see. Way back up here, right, we had a is equal to 2. Oops. A is equal to 2. So I'm going to take that 2 and plug that in, and I've got my point that I'm going to work with. So we're now going to have a slope and the point. So we've got our point here of 2, 3. We have our slope when I plug in my 2. And then I have a slope of 1/2. That's my slope. That's my point. So now we just do work. Y minus 3 is equal to a 1/2 x minus 2. So y minus 3 is equal to a 1/2 x minus 1. If I add 3 to that, that's where we get, right? And here, when you take 1/2 times 2, the 2's cancel, and that's where I get the -1. Some people ask about that because of fractions. All right. Not too bad, right? Okay, I've got one more for us.